Okay, guys, in this video we are going to solve another differential equation, variable separable, and in this case, this is the problem, and in this case they are giving us the initial condition, y of 0 equal to 0. That doesn't mean the constant will be 0. It could be, but it's not for sure. Okay, the first step is actually separate the variables, which we have already done before. Okay, so because here I see everything is in a multiplication, so it's possible to be variable separable differential equation. Okay, so exponential of 2y minus y over this as a division, exponential of y, and here I'm going to leave only the differential of y, equal to, here I'm going to do sine of 2x over the cosine of x, and then differential of x. Okay, now the next step is to take the integrals, alright? Take the integrals. Okay, so we have to solve the integral a and then the integral on the right side. So I'm going to split this in two problems. So I'm going to solve this a part and then b part, alright? Okay, so I'm going to solve a part here. So this integral is going to be integral of exponential of 2y divided by the exponential of y is going to be exponential of a single y, and then differential of y, and then minus this minus integral of this in the numerator, exponential minus y, y differential of y. Alright, I'm going to write first the exponential, first the y, and then exponential of minus y. Okay, so again this is the part A of this integral. Okay, this integral doesn't have a problem because the integral of the exponential is the same exponential, so it's just the exponential of y. But here we have a problem because we have to apply integration by parts, or we can apply, or we can use a formula in the table of the integrals, right? Because I don't have one, I'm going to use integration by parts. So I'm going to use this as u, and this as differential of v. So u is equal to y, differential of u is equal to differential of y, and then differential of v is equal to the exponential minus y, differential of y. We have to apply the integrals on both sides to get v. So this is minus, we need a minus, and we compensate with the minus outside. So the integral of the exponential is going to be minus exponential minus y. So let's use the integration by parts. This part is just the integration by parts, right? Okay, so minus, here the integration by parts is going to be u times v, y minus exponential minus y, this times this, u times v, minus the integral of v, differential of u, minus exponential minus y, differential of y. Okay, so this is going to be equal to exponential of y, and then minus and minus positive, plus y exponential minus y, sorry, here, and then this exponential of the minus y. So here the minus, it is going to be minus times minus positive, but I need a minus here to complete the integral, so I don't take it outside. So minus times minus positive plus exponential minus y. Okay, so the part A of the integrals is just going to be exponential of y plus, here I'm going to factorize the exponential of y, so it's going to be y plus 1 exponential minus y. Okay, let's check the minus. Okay, minus, okay, everything seems to be correct. Okay, so this is just the part of the integral of this. Now let's resolve for the part b. For the part b, is going to be the integral of the sine of 2x divided by the cosine of x, differential of x. Here what I'm going to use is a property of the trigonometric identities. Is going to be this sine of 2x is the same as 2 sine of x, cosine of x, divided by the cosine of x, differential of x. So I'm using this formula, sine of 2a is equal to 2 sine of a cosine of a. Alright, so that is the formula. Okay, I can see here that this cosine cancels. So the result, the 2, I can take it outside. The 2 integral of the sine of x, differential of x. Integral of the sine is minus cosine, so the result is going to be minus 2 cosine of x. And that's it. Ah, by the way, I forgot. Here, plus the constant. And here, plus the constant. Here, the constant of y, and here, the constant of x. However, there is no need to write two constants. One constant is enough. Okay, so I'm going to get rid of this. And let's go back to this place. So the integral of a is equal to exponential of y plus 1 exponential minus y equal to minus 2 cosine of x plus the constant. Okay? Now here at this level is implicit solution. Okay? And here, because here we have the exponential of y, and then below the exponential we have the y, it's going to be very difficult to clear the y. So I don't see how can we clear the y. ¿Cómo despejarla? So we leave it like that because it's very hard. Very hard to clear y. Okay, so we leave it as explicit solution. However, we haven't finished because we have to calculate the constant. And why we have to calculate the constant is because we are given an initial condition. Okay? So the way to calculate the constant is just to replace the value of the x and the y. So here the x is equal to 0 and the y is equal to 0, so it should be very easy. So if we replace here, it's going to be exponential of 0 plus 0 plus 1 exponential of 0 equal to minus 2 cosine of 0 equal, no, plus the constant here, plus the constant. Cosine of 0 is 1, the exponential of 0 is 1, okay? So this is going to be 1 plus 1 equal to minus 2 plus the constant. So how much is the constant? The constant is equal to 4, okay? So the specific solution, because this is the family of solution, the specific solution is going to be exponential of y plus 1 exponential minus y equal to minus 2 cosine of x plus 4, and this is the implicit and specific solution for that given initial condition. For another given initial condition, we are going to get another constant, so that is another solution. Alright? But this is the process to solve variable separable differential equations. So again, the steps. The step is number 1, separate the variables. Number 2, apply the integrals. Alright? Apply and solve the integrals. Number 3 was try to clear the y, but here we couldn't clear the y. And step number 4 is calculate the constants with the initial condition. Alright? So this is the example. I think with these two examples, it is enough to show you how to use the variable separable differential equation method to solve the differential equations. Okay? See you on the next method.